Hello everyone, welcome to my project demonstration. I am Saranya Krishnamurthy. I have done a project on healthcare for smartphone along with my friend Shruti Padmanabha as a part of my coursework on knowledge discovery and management at University of Missouri, Kansas City, Spring 2000. Healthcare is the most concerning part of our life. Immediate medical assistance for emergency needs is required to protect our precious life. In this fast-forward world, sensors contribute a greater portion towards it, but sensors want something more efficient than database to perform its intelligent and smart functionality. Ontology is the solution for it. The main objective of the project is to develop a smart healthcare system for medical assistance. The goal includes handling of data semantically and help sensors to make inferences based on situational, locational, and event information. The project focuses on the following specific problems: daily dynamic health information for the actors in the house, personalization of their workout preferences, personalized diet prescription, auto reminder, auto detector in case of an accident and sickness situations. Going into the technical details of my project, let me first introduce my actors: Mark, who's a healthy person, Tom, who's an old person, and Harry, who's a chronic diabetic patient. Following are my use case scenarios. Our smart home has an intelligent treadmill. All actors in the house access the treadmill as part of their daily activities. As soon as the actor ascends the treadmill, a smart device would display his health information. Then, it prompts the user to accept or reject his preset preferences. On acceptance, starts the workout, else prompts the user to change their preference. The new preference is then validated with his health constraints. On matching, stores the new preference, else displays a warning message. We also have an intelligent microwave in our smart home. When the person stands in front of our microwave, it gets activated and displays his prescribed diet in calories. When the actor places his foot, the microwave calculates its corresponding calories, and if found matching it to his health constraint, eats the food, or else throws out an error message that the food is not matching his diet. Harry, the diabetic patient, has to take insulin every 6 hours. The sensor ring which he had worn reminds him of insulin every 6 hours. Where the old person falls down on his living room. The television senses it and sends signal to phone. The phone receives the signal and sends a voice mail to helpline and simultaneously informing the family members. There is a scenario where Mark, the healthy person, meets up with a car accident. The car, in turn, signals the phone. The phone intimates helpline and family members. Ring that Harry has owned also has a thermostat attached to it. The ring senses the body temperature. On increase to a certain threshold, signals the phone, thereby informing helpline and family members. This is the overall design of my project. Ontology acts as a backend. Jenna acts as a media to talk to ontology. The activities are controlled by web services. The flow is controlled by middleware. Simulator engine randomly generates array of inputs and takes the outputs. Let me demonstrate my ontology. Here are the list of classes I have created. The state class contains the list of initial and final state for each of the activities. Following are the list of restrictions. Most of them are universal and existential. These are the list of properties and instances for my project. The instances are individually mapped to the properties. Following is an example of one such case. The Jambalya view gives an overall view of concepts and relationship created. There are different varieties of options available to view. In order to share and reuse our project, we have made each of the devices as composite web services and activities as atomic web services. The created ontologies are used by the web services using Jenna, which gives a programming framework to these ontologies. I use NetBeans to code for my project. I've created a web application and coded each of the devices as web services. The following are the list of activities and they are existing as web service methods. I have used a third-party middleware which controls the flow and also acts as a decision maker of which services to be called next. Following chart depicts of how my middleware works. It accepts an array of input from the simulator engine, sequences it based on time called, and calls the corresponding services, sends the output back to the simulator engine. This is the code perspective of my middleware. Decision.java is the web service for the middleware. These are the list of web service clients that I have created for the middleware. Third-party controller is the web application. Inputs are sent to the middleware in TLV format. T stands for time, L for location, and V for value. These are the basic 9 test cases that covers my use case scenario that I've implemented. Out of these 9 test cases, I've randomly picked up 2 for demonstration. The inputs are as follows. Mark assigns the threadmill and gives accept for the preset workout preferences. The other is Tom, who falls down on the living room. How my middleware reacts to the input. Clicking on Touch Web Service. Here I paste the input and click on the flow control. Here I get the output. In order to make a more intuitive understanding of my output, I have tracked the flow in a database. Here we are logging which web service calls, which web service is getting called, the call time, and the output of each of the web services. Finally, I would like to thank Dr. Yugi Lee, my professor, and the teaching assistants for their valuable guidance.